7:17 a.m. on June 30th, 1908, the sky over Siberia split open. 80 million trees snapped like matchsticks. Not burned, flattened. No crater, no wreckage, no body. So, what exploded? Whatever it was, it hit with the force of a hydrogen bomb. But in 1908, there were no hydrogen bombs, no satellites, no cameras, no recordings, just shockwaves that knocked people off their feet, hundreds of kilometers away, and skies so bright in Europe you could read a newspaper at midnight. London didn't know why the night turned white. Paris didn't either. They just knew something was wrong. Ground zero, no witnesses, not one. An explosion without an object. A crime scene without a weapon. A disaster without a culprit. So let's ask the obvious question. What leaves devastation? But no debris, meteor, comet, alien technology? A weapon that shouldn't exist? Science has answers. Plenty of them. They just don't agree. If this happened today, we'd call it a failure of intelligence. In 1908, we called it an accident. For years, no one even went to look. The place was too remote, too inconvenient, and maybe too uncomfortable. Because once you walk into that forest, the evidence doesn't behave. Trees point away from the blast, but some are still standing, stripped, like telephone poles. Physics says that shouldn't happen. Yet, there it is, frozen in time. Tunguska. This isn't a story about what exploded. It's a story about how confident we are that we already know. Stay with me, because certainty is about to crack. And when it does, everything we thought we knew about that morning will look like a lie. It's already happening. Witnesses look up, and then the sky burns, a pillar of fire, a roar like artillery, heat so intense, clothes catch fire. What did they see? Every account agrees on one thing. Something detonated before it hit the ground. Now, look at the evidence. Trees don't fall inward. They don't collapse randomly. They're blasted outward. Flat, radial, like a giant hand pressed down from the sky. This is not an impact crater. This is an AR burst, 5 to 10 kilometers above Earth. That's the problem. That's always the problem. Seismic stations registered it as an earthquake. But earthquakes don't come from above. So what releases that much energy in the air without touching the ground? This explosion released more energy than Hiroshima. Let that sink in. No uranium, no plutonium, no bomb. In 1908, physics demands a source. Energy doesn't appear, it converts. So, where did it come from? Meteor theory says stone or iron. Fine. Then, show me the body. No fragments, no crater, no metallic debris. Nothing. A comet, ice, and dust? Then explain the heat. Explain the pressure wave. Explain the seismic spike. Every answer fits some of the evidence. None fit all of it. That's not an explanation. That's a compromise. So here's the real question. Not what exploded, but how. How do you get nuclear-level energy without nuclear technology? How does something detonate, disappear, and leave geometry behind? Because whatever happened over Tunguska didn't leave a body. And crimes without bodies? They're the hardest to solve? Next, we meet the suspects, and not all of them are human. They start digging. This is where it should be. Right here, the ground is exposed, flat, ordinary, but there's nothing. No crater, no scar, no wound in the earth. Every explosion leaves a mark. Every impact leaves a signature. This one left a question. From space, it looks clean. Too clean. An object with the energy of a nuclear weapon should have punched the ground. Hard. So, where's the hole? They search for fragments. Iron, nickel, stone, anything. Nothing metallic, nothing exotic, no meteorite, no debris field. That's the second problem. Meteors don't evaporate politely. They break, they scatter, they leave pieces behind, unless there was nothing solid to begin with. So scientists dig deeper. Literally, they test the soil. Radiation? No. Isotopes? Inconsistent. Chemical traces? Messy. Ambiguous. Not zero. Not enough. The data doesn't point. It shrugs. Some layers look disturbed, others untouched, as if the blast respected invisible boundaries. Explosions don't do that. So ask the uncomfortable question: what kind of force flattens a forest, lights up half the planet, registers as an earthquake, but leaves the ground mostly intact? No crater means no impact. No impact means no body. And no body means no easy answers. Investigators hate this because absence cannot be measured. It cannot be weighed. It cannot be photographed. You can stare at it forever, and it will never confess. This is where certainty starts to rot. Because if the Earth wasn't hit, then whatever exploded never arrived, or never existed the way we expect things to exist. No crater, no fragments, just damage, without a fingerprint. And that's when theories start to panic. They're finally here. 19 years. Too late. This is the crime scene, or what's left of it. Because in 1908, no one came. No scientists, no instruments, no measurements, just rumors. And a blast no one wanted to explain. The Soviet Union seals itself off. Borders harden. Information slows. Curiosity becomes inconvenient. By the time the first expedition arrives, the forest has already begun to heal. Time doesn't preserve evidence. It erases it. Imagine trying to solve a murder 2 decades after the body disappeared. No blood, no weapon, no witnesses who remember clearly. That's Tunguska. A cold case from day one. By the time science shows up, the questions have aged. And aged questions lie, angles blur, details contradict. This isn't just a lack of data, it's corrupted data. And corrupted data builds confident theories on rotten ground. So ask yourself this: can you solve a crime when the crime scene is gone? When time itself has wiped its fingerprints clean? Science didn't fail here. It showed up after the truth had already left. And then it stops. No more suspects, no more arguments. Just one word: meteor. That's the answer. The official one, the one textbooks repeat, the one documentaries settle into. Case closed, right? A stony object or a comet fragment entered the atmosphere, blew apart midair. Problem solved. Except it wasn't proven, it was accepted. There's a difference. No crater? Airburst explains it. No fragments? Vaporized? Odd patterns? Atmospheric physics? Each problem didn't disappear. It got managed. This wasn't discovery. It was negotiation. Most likely. Not demonstrated, not verified, just comfortable. Because science doesn't just chase truth. It also avoids chaos. A meteor is familiar, predictable, non-threatening. No new physics, no uncomfortable questions. But here's the problem. Every loose end didn't get tied. It got trimmed. The mystery didn't vanish. It was buried under consensus. Solved mysteries don't sound defensive. This is the moment everyone relaxes, the moment curiosity shuts down. This isn't the end of the investigation. It's where it went, silent. Because once everyone agrees, no one looks closer. Watch closely. This is the official explanation: a comet or a stony meteor, breaking apart, releasing energy. Problem solved. Except the numbers don't sit right. Start with energy. The blast was too strong for a loose pile of ice and dust, too strong for fragile stone. So scientists adjust the mass, then the speed, then the angle. The explanation stretches. Next problem: debris. A comet should leave traces, dust, chemical fingerprints, something. But Tunguska left almost nothing. So the comet gets stranger. It becomes softer, more fragile, more convenient, until it behaves like nothing we've ever observed. Some anomalies show up, but not cleanly. They don't scream comet. They whisper something else. If the explanation only works when you keep adjusting it, is it an answer or a placeholder? Comets don't detonate like bombs. They don't flatten forests with surgical symmetry. At least, not the ones we know. The theory doesn't just explain Tunguska. It requires Tunguska to be unique, a one-off, an exception to the rules. Science hates exceptions, but it hates rewriting rules even more. So the comet survives, not because it's perfect, but because every alternative is worse. If this were airtight, why does it feel so defensive? Why so many modifiers? So many special cases? Because explanations that fit don't need protecting. These never make it to the board, not because they're proven wrong, because they're uncomfortable. This is where the room gets quiet. Say the words out loud. Mini black hole. Too exotic, they say? Too speculative? Fine. But ask the question anyway. Could something pass through the planet, release energy, and leave almost nothing behind? Not likely, but not impossible. Next card, antimatter. Matter meets antimatter. Energy released. Total annihilation. Sounds ridiculous. Until you remember, E equals mc squared. That's exactly how you get enormous energy from almost no mass, still no evidence, still no trace. So it's ignored. Now the one everyone rolls their eyes at. Directed energy, experimental weapons, no proof, wrong era, free system, dismissed. And they're probably right. But notice the pattern. These ideas aren't killed by data, they're killed by tone. They're labeled crazy before they're labeled tested. Science says it's open to questions, but only certain ones. Why does ridicule show up before refutation? Because unanswered questions are dangerous, but unaskable ones, they're safe. This isn't about believing fringe theories. It's about noticing avoidance. When explanations feel fragile, questions start getting policed. And that tells you more than the answers ever could look closer. The explosion isn't the point anymore. The mystery is how we pretend we solved it. Meteor? Consensus says yes. Comfort says yes. Truth? Maybe not. We like answers. We need them. We trust them. But what happens when answers arrive first and evidence shows up late or not at all? The danger isn't ignorance. It's premature certainty. We call it science. We call it progress. We call it solved. But maybe we've just negotiated comfort. And comfort is never proof. How many solved mysteries are just socially acceptable guesses? And how often do we stop looking because the answer feels safe? Tunguska wasn't about a meteor or a comet or disappearing energy. It was about certainty itself. The real danger isn't what we don't know. It's what we stop questioning. It's quiet now. No crater, no fragments, no final answer. If something like Tunguska happened tomorrow, would we really understand it? Or would we just name it